It's a pleasure to have you here. Iori Mizutani, doctoral researcher at University of St. Gallen. We talk about your presentation, Explainable Industrial Automation, together with Daniel Müller, head of GS1 System, GS1 Switzerland. Iori, your topic is pretty complex, especially for people who are not in that field. So let's take one step back. Why is it important for companies to dive into this topic?
So thank you, Vi. I will try to make it concise. But so industrial automation systems have a long history, but especially after the Industry 4.0 has become hyped term, and lots of innovation and technical roadmap have been deployed by relatively large enterprises. And in my view, the new paradigm can be adopted only if it is worthwhile. Concretely, it can have financial benefit, but that is often the gap between the research and the industry. So one of my mission here is to bridge between the academia and industry and find out what is actually missing. And one of the things that is missing is a semantic interpretability to actually connect everything so that we can extend value chains in the existing systems.
If I may add, that means there is a lot of work in the semantic to do, if I got you right. And if I remember the slide regarding the supply chain in your presentation, when you take these pieces isolated, there are some, let me say, interoperable standards like or identifications like GTIN, serial shipping container code, serialized GTIN, the SGTIN, and things like that, which are a prerequisite for this industrial automation systems. Is this conclusion right so far?
Indeed, this standardization of IDs has been a magnificent impact on the interpretability, but that is not only the factors that is enabling that would enable semantic interpretability in the future, because GS1, for instance, has been doing a very good effort to, for instance, to interpret with ISO IDs. Just adapting, not just adapting pure identity of those, but also to introduce new technologies like digital link, as I have briefly discussed, and that's the interpretability on the data and the scheme. But to achieve the real interpretability, we also have to share the context, the same context that can be used by different operators in the system. So to aim for the real semantic interpretability, we have to think about all the other meta information that is mapped with the ID. So for instance, not only to talk about the ID scheme and how it can be identified with the specific data carrier, but also how this ID is being used for the specific context, such as to identify the source material quality and how it's passed the certificate process, and how is it actually ordered through the customer and so forth. Mapping all these different players in the system is kind of the biggest challenges for the industrial automation systems.
And in order that this whole system works, it's important that every supplier is participating in the whole process. How do you get to that point, that everybody is really working on the same goal?
To the same goal. So especially in a manufacturing automation system, regardless of what it is producing, you want to know and you want to track the individual object to extend their value chains in the system, to establish the mechanism that can interpret and translate and allows us to exchange the context between different providers. And that is the high level goal, but on the ground, that is inherently have problems that they are using different IDs and they are using different machines, and that is quite difficult to communicate with each other. So one by one, we need to tackle these technical problem, but not also technical problem, but also the political and regulational barriers in between them.
You also said in your presentation, the future IAS should be explainable to different stakeholders.
Mm-hmm.
Why is that so important?
So the explainability is an umbrella term to describe many non-functional requirements in the system, such as transparency for eliciting the logics in the system, and accountability to provide information that is necessary to assure quality and also passing the regulations. Traceability, this is GS1's specialty, and to track the object on the supply chain, but not only to track the object in one place, but also throughout the entire supply chain. And as we discussed, interoperability between different components in the system, not only between machines, but machines to human and humans to humans.
Do you see already pressure in certain industries? Like, is it typically suffering industry like car production, which would profit?
The car industry, I myself have not been in touch with any automotive industry, but I would say there have been always some sort of pressure, and depending on the size of enterprise and the level of automation, they have their own problems. And especially for the migration costs, it is relatively easier for the large enterprise to implement new paradigms and try to make it interoperable try to say that they are interoperable with other domains. But for small to medium-sized enterprise, it is always difficult for them to create actual values on adapting those new technologies. But at the same time, this new paradigm is a pleasure for those companies. So what I want to point out here is to try to keep an eye on how it is affordable for those companies, and try to make those semantic interoperability is actually feasible in between these companies.
And, Iori, I'm not 100% sure if I got you right. You mentioned big companies in a way have it probably easier to go in this direction than small and medium enterprises. That's something I guess everybody sees as well. If we take a 360-degree view on what is happening, and to stick a little bit to a common element, EPCIS. EPCIS is more or less a tool which allows you to trace events and to have real-time information depend on the network you're in. And is it a little bit comparable to what has happened in, for example, what Migros has done in the fresh food with their suppliers from abroad to track and to trace? I know it's not production, it's also production, but completely a different approach. But these basic technologies which are needed can be provided by third parties, because probably the small and medium enterprises themselves are not always capable to build their own intelligence or systems on that. Or do you see, or do you think this is just a matter of time that this will be maybe a commodity also for smaller companies, or yeah, in the context, I think, as you said, we are not only also we are not just in front of a huge wave. I think that this will last some years until you have a broader implementation of systems like you introduced in your presentation. What do you think, very concrete, what can a SME do to today already, that they won't end up in a big surprise someday and lose their business?
So I think, Daniel, EPCIS is a good example, because for SMEs, especially in industrial domain, unlike retail product in retail markets, EPCIS has not been quite prevalent to track industrial parts, like metal parts, that is to be used for airplanes and trains, because they are fundamentally different from like fresh foods or like detergent that we can find it on the supermarket. That is different. They have different ecosystem and in the supply chain, and they have different life cycle in the supply chain. So for small to medium enterprise to adapt the EPCIS to track the object, it is still hard to think that it can immediately give a profit by adding EPCIS repository of their own and operate their own repository to allow other supplier and operators to use that information in their domains. But as more and more players in this ecosystem start adapting the common platform, including EPCIS, but not to that far, not to that specific implementation, but for instance, like using digital link, or more in broader sense, using the web principle to connect things and to be discoverable by other partners. And that, I think, will bring us benefit to seek for the semantic interoperability in different players and cross domain in the cross market approach.
Okay. Okay. The visibility across industries and markets.
Mm-hmm.
Okay.
And yes, go ahead, busy.
No, say what you want to say.
So in EPCIS and the GS1 domain has been particularly focused on how to track the individual object. But as I briefly mentioned in the talk, in the industrial automation system also involves the control of machines. So it is not passive information; it is the active involvement in the control logic in the factory, and that is different from the traceability in the logistics, for instance. And those control information can also be connected to, for instance, traceability information, and they can be interconnected, and they can optimize their operation as a whole. And that's the broader view of the semantic interoperability.
It's pretty complex. Are companies able to handle this topic on their own, or how do companies have to work along the supply chain to achieve their best performances?
It is very relevant to the questions, and technically, yes, by creating the silo and implementing the proprietary walls. But this is not only about the supply chains, but it is a trade-off between operationally feasible versus make it open as possible and leave the extendability of their existing systems or operational flow. And as as myself being a researcher, I of course go for the openness and to seek for the possibility to extend the value chain as much as possible, but it is still hard questions to answer by one single point of view. But how the company should tackle this openness problem, it's beyond my domain. So
yeah, I think there are things like security, also secrets of production, and how do I manage certain things. But you know, I'm still at the point where honestly I think maybe I'm the only one, but I don't think I have already understood the whole system, how it could look like if we have a broad rollout of industrial automation systems. But is one imagination maybe completely stupid? But I was always thinking about when we were talking maybe 15, 20 years ago, or almost, when we were talking about Internet of Things. I take my milk out of the refrigerator, and the message will be transmitted to the, not to the cow, but to the farmer. Hey, there is a milk gone. I have to take some milk from the cow to have a perfect replenishment as well. Is it a little bit this direction it will go, but even further? Because talking about machines, if I have a specific machine running, don't know, to build forms for cars, or I don't really like the automotive, to be honest, as an example, because it always looks like they have all already invented. But if a machine is going to break down, and you have the sensors which will tell you on time, hey, pay attention, this specific major part is close to the, or near to the end of its lifetime, of the life cycle. And this sensor does really without human intervention, goes back to the originator, and the factory starts without human intervention to produce this part, that it will be replaced on time, for example. Is this one picture we can imagine of industrial automation systems? Is it this way it is going to take? Also not after tomorrow. I'm sure it will take some years, but this is probably near to the vision. Or do you have another example?
But Daniel, you got a really good point, like human intervention. Do we actually automate everything and then put everything on the AI and let them do the job? My answer is no. A human must be involved in the system. And this semantic interoperability is not to achieve the complete automation system, but to enhance the system so that human operators can actually utilize them. For instance, to know when this machine is about to break down and when the human involvement is needed to replace some parts to fix the operation. And in a higher level, like to provide accountability if this robot is doing the job right. The logic of the robot operation, for instance, must be composed by humans. Of course, there would be a technological aid that humans can utilize it to compose the operation design, but at the last segment of this process, human must be there to decide this is good, this is bad, and from from different point of view, because human is universal, universal parts, universal, maybe not right choice of word, but human can think about things in multidimensionally. Like they can think about how we hire this operator and ask him to work on this robot, and think about how often we are spending money on replacing parts, and how fast we can produce, and when is a deadline, and who is a customer actually ordering this, and how we can optimize this ordering process and so forth. So this kind of organization can only be done by humans. But in order to do that, what can we do to enhance the existing system? And that is the contribution of this semantic interoperability, not just to offload everything to AI.
Now the question is where to start, because as I said, pretty big field. Where do we start?
So I think we are in a good position where we can already receive the benefits from the organizational effort. Like I briefly mentioned in the very end of the talk, like GS1 and other alliances, technical alliances have been doing putting a particular efforts to interoperate with each other in many directions, not only the technical details, but also in the kind of having shared common view to treat, for instance, to provide uniform information exchange between different players. And having said that, we have to think about how can we exchange and how can we communicate beyond the border between different components in the system and different layers of the systems. And one of the methods that I want to propose is a web of things, and that's how I would approach from here.
Iori, you work as a researcher and you're very much in that field, and it's a lot of theory. So do you have a lot of exchange with people who are really in the industry to see what's really going on in reality?
In reality is always hard, right? So yes, I have several contacts, but they have their own problems. And although if I need to hit the ground, but at the same time as a researcher, I have to abstract a little bit and give an overarching approach that can potentially solve this interoperability problem in next 10 years, for instance. So as many problems as I collect, I think the approach will get mature. So I hope this will help or just give some insights on the future industry automation systems.
Thank you very much for your time, Iori Mizutani of University of St. Gallen. On behalf of GS1 Switzerland, we'd like to thank you for your time. Now, we have your contact details right here for everybody who wants to contact you, get in touch and have an exchange about this topic.
Thank you so much. Pleasure to talk to you.
And thank you again, of course, Daniel Müller of GS1 Switzerland. It was great.